Hello and welcome back. In this lecture, we are going to try to summarize what we have learned in the first section of this course. Let's start. In automotive quality planning, two dominant frameworks define how organizations manage product realization: the AIAG APQP and the VDA MLA. The APQP, the Advanced Product Quality Planning, is the American-based system developed by the Automotive Industry Action Group. The MLA, the Maturity Level Assurance, is the German-developed system under the Verband der Automobilindustrie. Both arose from the same industrial challenge. How can we ensure a predictable, capable, and defect-free product launch every time? The AIAG APQP provides the structure and deliverables, while the VDA MLA provides the measurements and transparency. While their approaches differ, their destination is identical: a robust, validated product and process ready for series production. The AIAG framework emerged in the 1980s during the rise of US automotive standardization. The Big Three, Ford, General Motors, and Chrysler, sought to unify supplier expectations under a common quality planning approach. The American system emphasizes structured project flow, documentation, and deliverables, each step verified by evidence such as design FMEA, process FMEA, and PPAP package. On the other hand, Germany's automotive industry, led by OEMs like BMW, Mercedes-Benz, and Audi, had already developed its own rigorous system of milestone reviews and maturity audits. Instead of fixed deliverables, VDA focuses on maturity progression measured at 8 milestones, M1 to M8. Each maturity level represents a quantitative evaluation of readiness using the traffic light logic: green, yellow, red. Thus, the VDA approach is less about what documents you submit and more about how capable and stable your process and design are. Both frameworks define product realization from concept to series production. The difference lies in how they structure and measure progress. In APQP, the emphasis is on delivering the required documents: FMEAs, control plans, DVP&Rs, and so on. MLA takes a slightly different angle. It focuses on how mature and how risky the product and process are at each milestone. APQP runs as a straight 5-phase process, from planning all the way to continuous improvement. MLA uses milestones, M1 to M8, and maturity levels, ML0 to ML7, to measure progress. The structure is more granular, giving OEMs a finer checkpoint system. In APQP, progress is shown by completed tasks and documents, basically checking off what has been done. In MLA, progress is shown with a red, yellow, green dashboard, which visually communicates maturity and remaining risks. It's less about documents, more about status. In APQP, the big validation moment is the PPAP package, when you hand over the package and the customer approves the release to production. In MLA, the equivalent checkpoints are ML6, product and process validated, and ML7, ready for series production. APQP reviews often happen internally and then again with the customer at program gates. MLA is more collaborative. Supplier and OEM teams sit together in a roundtable format to openly review maturity and risk, milestone by milestone. At SOP, APQP delivers the PPAP package, the formal evidence for production approval. MLA delivers an ML7 green maturity report, showing all risks have been reduced to acceptable levels. APQP follows the classic PDCA cycle. MLA focuses on a triad approach: plan the work, measure maturity and risk, and assure the result with OEM involvement. To align the two systems, practitioners map each APQP phase to its equivalent MLA maturity stage. In the APQP Phase 1, we're simply trying to answer a simple question: can we actually make what the customer wants? In VDA terms, this is ML0 to ML1, very early maturity. We're defining customer expectations, checking feasibility, identifying early risks, and building a realistic timing plan. In APQP Phase 2, product design and development, we're creating the design, reviewing risks through the design FMEA, and planning validation tests through the DVP&R. In VDA, this corresponds to ML2 and ML3. The design is being developed, then frozen. The key evidence here is usually the A sample, the first physical representation of the design. In APQP Phase 3, the question becomes, how are we going to manufacture this? We're developing the production process, equipment, tooling, layout, inspection methods. Process FMEA helps us find process risks before we ever cut the first chip. In VDA MLA, this is ML4 and ML5. Process design and process maturity. Your B-sample parts come from early pilot processes, not full production, but close enough to test manufacturability. In APQP Phase 4, we're proving the process really works. Pilot production is running on near-final tooling, and we conduct runner rate to demonstrate capacity and stability. Capability studies confirm that key characteristics are under control. This maps directly to VDA's ML6, the point where both product and process are validated. The output we all know, the PPAP package. And finally, in APQP Phase 5, we're monitoring performance, solving issues quickly through 8D problem solving and feeding lessons back into future programs. In VDA, this is ML7, Series Production Maturity. This is where we close the loop and prevent problems from repeating in future launches. This alignment ensures that each APQP phase ends with the right MLA maturity milestone. No duplication, just different perspectives. APQP phases and MLA levels are not identical, but they interlock seamlessly. An effective organization uses MLA checkpoints within each APQP phase, maturity validation within structured planning. One of the biggest challenges for global teams is navigating different terminologies and document expectations. Even though the words are different, the intention behind them is usually the same. This table helps you translate between the two languages. Most global OEMs now require dual compliance, recognizing both frameworks simultaneously. For example, Volkswagen, BMW, and Mercedes-Benz expect full VDA MLA compliance but accept AIAG-based documentation as evidence when structured under MLA milestones. On the other hand, Ford, GM, and Stellantis expect PPAP package, may request VDA maturity data for shared European suppliers. Many multinational suppliers like Bosch, Continental, and Magna have built internal hybrid systems that merge both methods. This hybrid approach reduces redundancy, harmonizes communication, and allows one global quality language across programs. By merging structure and transparency, organizations achieve both compliance and agility. That is the end of this section. The next lectures will take us from framework theory to practice, exploring each core document like FMEA, control plan, PPAP, MSA, and SPC, and how they evolve through the phases.